Alright, this is a graphing polynomial worksheet, and we're going to label the roots, the y-intercept, the relative mins and maxes. We're going to throw in a little increase and decrease interval too. This, every single one of these fits on Zoom standard, so you don't have to do anything fancy. It's just 10 left, 10 right, 10 up, 10 down. It'll all fit. Okay, let's do the first one here. So we'll hit y equals, that's where we type the equation in. And I'll hit the variable button x and then raise it with the caret key to the third power, push myself out, and I'm going to graph x cubed. Let's see, zoom, and then number 6 is zoom standard, and that way it looks exactly the same here. So this is the mother of all cubic functions. It's down, well, positive and odd, right? So it's down on the left and up on the right, and it kind of swirls through there. In calculus we call this a saddle point, but it increases, it stops increasing for just an instant in time, then increases. So we say this is basically an increasing function. And the x and y intercept and the zeros are all the same thing. Because it goes through 0, 0. And that makes sense because 0 cubed is 0. So there's the point 0, 0. So if I cube 0, I get 0 back if I was making a little table here. Alright, I need two other points, just something. If I cube 2, 2 times 2 times 2 is 8. So I go 2 over and then up 8, which would be right there. And the negative 2 is negative 2 times negative 2 times negative 2. 3 negatives multiplied together is negative 8. So I go over 2 and down 8. So it looks kind of like a straight line, doesn't it? But it curves. And this is the mother of all cubic functions. It flattens out a little bit more than that, as you can see. But I did my best to make the general curve here. Okay, let's try another one. Ooh, this one is negative and odd. Remember, the highest power controls the shape of the curve. So, let's type this one in. So this one will be up on the right and down on the left. That's what we're looking for. So I'll insert a negative sign. Make sure you use the negative, not the minus, because it'll mess things up. Plus 2x squared, push myself through, and then 3x. And I forgot either I hit it or it messed it up. Insert addition. Alright, so that's the same thing typed in? Yes, so we're good. Hit graph. And again, I made these all fit on Zoom Standard. So once we have Zoom Standard set up, then that's what it is. Ooh, beautiful. Up on the left, down on the right. Negative and odd. See how it matches? It's like two parabolas smashed together, but they don't have the same characteristics as parabolas. Okay, it appears that the zeros of the function are at 1, 2, 3. So to check that out, I'm going to hit the trace key and then hit 3, and that'll jump me right to 3. And yes, 3, 0. And I have to make sure that it's 3, 0. It looks like it goes through negative 1 and 0 as well. If I hit 0, enter, for sure, yep. And if I hit negative 1, enter, I'm in the trace mode. So negative 1, 0. So you jump anywhere you want to as long as you're in the trace mode. Okay, so let's put those zeros of the function on there. 1, 2, and then the other one was at 3. All right, let's go for the relative mins and maxes. So that's a left-right guess situation. So we have second, calculate. Minimum. Left, made the mark. Over to the right, made the mark. Shout out to my daughter. She allowed me to use her graphing calculator from high school. She's now in graduate school, so shout out to Emma. I feel like Sean Alexander, he did shout outs when he did his press conference at the Super Bowl one year. Okay. So around -0.5 and around -1-ish. Okay. So I'm going to go over -0.5-ish and kind of close to -1. About there. Okay, and I'll put the point here, I'll label it -0.54 and -0.88. Alright, now do the max. So I can calculate max. Mark. And back, left, right, guess. Okay, so it's close to 2.6, but it's 1.8 and a little bit bigger than 6. So close to 2, up 1, 2, 3, 4, 5, 6, and a hair more. Okay, so I'll put an arrow and point to that. That would be the point. That'll be the point 1.87, comma 6.06. All right. So the thing. Oh, and it crosses at 0 there. Okay, because it's +0 at the end here. The last number in the polynomial, when it's in standard form, is your y-intercept, because it makes sense. If you put 0 in, you get 0 back, and that's the last number there. So it comes down, comes up, comes back down again. All right. So I found the roots. The roots are x equals 0, x equals -1, and x equals 3. Those are the roots. I found the y-intercept. The y-intercept, you can see it graphed there, is y equals 0, because it crosses at 0. And the relative mins and maxes, I've labeled them. There's the max. Here's the min. Okay, so the min and the max. Now, let's do intervals of increase and decrease. So it's going down. Let me read it from left to right. It's going down here, and down here. And then I need another color. Going down there. Oh, here's my green. Here's my green one. It's going up here. So if you're riding a roller coaster, it's going down, up, down. So it is, and we base this on the x values here. So let me see, make sure that I'm writing here on this still. It is increasing in between two numbers. So it's increasing between these two x values. So we put the small number on the left, the large number on the right, and it's increasing between these two x values. That's the way we write in between in math. So x is less than this number, x is greater than this number. We read the inequality from the inside out. Okay, now it's decreasing on the outsides of those. So decreasing when x is less than this x value, -0.54, and when it's greater than this x value, x is greater than 1.87. Boom, boom. All right, so that pretty much takes care of that. Oh, let's see what else is on this worksheet. We got all the way at x cubed, but then I really notch it up here and do x to the 4th, so it's kind of crazy. Here, let's type one of these in together. Number 8. So we got x to the 4th power, push myself through, minus 7x squared plus x plus 5. Enter. All right. And ba-boom. Let's see. Yep, that's it. And we go to graph, and it should fit. Whoa, it's like 3 parabolas smashed together. Positive and even. So it's up on the right, up on the left. So it's up on each side. It decreases, increasing, decreases, increasing. Now, for these ones here, it looks like it crosses at 1, but then it crosses at some weird number. So when you're going through this one, you can't, we hit the trace button and say, hey, it looks like it crosses at 1. I know that 0, 5 works because that's the y-intercept. That's listed. You can kind of see it right there, 0, 5. It looks like it crosses at 1, and sure enough it does, but then I really can't guess and check this. I need to use the left-right guess from the zeros of the function. So I hit the trace key. No, I don't hit the trace key. I hit calculate. So I can calculate, and I'm going to look for the 0 of the function. So right in here, left, right, and guess. So it crosses at an odd number. It crosses at, and then that means scientific. That's scientific notation. That's basically the calculator did a little hiccup. That means 0 in all intents and purposes. And then this would be 2.38, 2.39. So if if you're making your mark here, it's basically ish right there. And it also crossed at 1, didn't it? So it crosses at 1. Okay, so that's how you start that one, because you're going to have to do a little more searching for these. And then these probably don't come out to be nice places, so you got a left-right guess to find the mins and maxes. All right, so that gets you started on this. Polynomials, negative and odd, up and down, right? And then decreasing, increasing, decreasing. And then positive and even. It's up and up, and then it decreases, increases, decreases, increases. All right, have fun finding all those points.